Hello, Michael and David. This is the beginning of making a cam. It's not a cam like that goes in an engine of a car. It's a cam that goes in a press. So this is the side view. It's a round shaft that is the diameter finishes at 2.999 to 2.998. So the precision has to be between those two numbers. So it's plus or minus half of 1/1000th of an inch. Luckily, after I'm done with it and I heat treat it, it's going to get finished at a grinder. Grinders are more precise than lathes. So I'll be able to leave extra stock on this, and then they will grind it down after heat treating, because I'm cutting it soft and then it gets heat treated, case hardened, just like the shackle of a master lock, you know, carbon hardened up to, that's a knife edge kind of hardness, 56 to 58 Rockwell. This is a hand-drawn drawing, probably from 30 years ago. So the overall length of it is 11.38. So 11 3/8, and it finishes at 3 inches. So I had to use 3.5 inch stock. But if you look, there's a whole lot getting cut out of here. And then an angle and a flat. And then it gets some, those are cutaway. The dotted lines show you that those are kind of like as if you had see-through vision. That's those 4 holes that are drilled and tapped. So those are threaded holes, and somewhere up here it says 3/8 16. That's national course. That's a standard 3/8 bolt. So the first thing we got to do is I'm making 2 of them, so I'm going to cut. I already bought twice as long a piece and I cut them in half. So there's one, and there's the other one. So I have to put it in a vise and stand it up like this, and then put a center in it to be able to keep it running true on the lathe, and I'll explain that when we get over to the lathe. Okay, now we've got this stood up in this vise, got it centered. I know the exact center of this, and I'm facing it off because I won't be able to reach this whole edge from the lathe, so I'm putting a clean square finish on it here. You see I've cut some here. I'm just trying to get this saw cut cleaned up. It's a rough cut in the saw, and it comes out maybe a 1/16th out of flat, so then you just cut a little bit at a time until it cleans up. So this is going to take 15 thousandths. It's a pretty light cut, and it's not quite enough. Probably another 10, and then we'll have it cleaned up, and then I'll drill the center in it. Now we're taking the last 1/1000th with a much finer feed rate with a little bit of oil on it. You see some smoke, but it's worth it because it gives you this mirror finish. Then we'll put the center in. Okay, we got that looking really nice. See a reflection in it. That's the face mill. It uses carbide inserts. It's got 4, these are square inserts, so when they get dull you turn them and you get 4 turns, and then you put a new set of inserts in. They can run a lot faster than high-speed steel. So this machine has a tool umbrella with 20 tools in it. So I'm going to go to tool number 4 and then center drill this. A little oil. And it's going to peck up and down 4 times to clear the chip. And there it is. And that little center is a 60-degree center. And you'll see how that works in the lathe to support the piece. Okay, this is my CNC lathe. This is a Cincinnati Falcon 200. It has an 8-inch chuck and a 12-tool turret, and it has a hydraulic quill for a center, and I'll show you how that works. This was new in 1997, Windows NT, touchscreen. This was originally owned by the Department of Energy in Oak Ridge, Tennessee, where they made the bombs. And I got it about 8 years ago. So I'm going to have to set the camera up, and I'm going to show you how I'm going to hold that center. Is going to be supported by this 60-degree center, which has heavy ball bearings in here to handle the load, and then the other side is going to be held by the chuck, and then we're going to do all the turning in between. We're going to be able to turn at a high heavy rate because it's supported on both ends instead of just one end. Okay, we're going to leave just a little bit of material in here. We're going to slowly advance this quill with the live center. Pretty slow. The pressure's down low. Okay, then I just bump it in just a little bit more. And then holding it against this center, and then I press clamp. And these 3 are going to come in with hydraulic pressure. It would cut your finger off if you were in there when it came down. Okay. Now we've got a good grip on it. We can do some heavy cutting. Okay, we're ready to go. This is 3.5-inch hot rolled steel, just mild steel. We're going to use this carbide insert cutter. You're looking at the back of it. The cutters face this way, so the chips go downward. So I'm going to close the door because there's a lot of coolant, a lot of hot chips flowing. It's going to come in. It's going to turn 750 RPM. And as long as it doesn't chatter, we're going to go at 10 thousandths per turn. So every 100 turns, it'll go an inch. So at 750 RPM, it's going 7.5 inches a minute. It'll be about to here in a minute. We're cutting about 10.8. We only need to make about 2 more passes to get down to just above 3 inches. Here we go. This is going through ballistic glass now. Sounds good. Try a little more speed. That's 15 thou. About 11 sounds good. Now it's getting all boogered up. Here's how fast it's traveling. The diameter it's cutting is 3.3. We're cutting 0.1 inches off each side, 0.2 inches in diameter. And we're at, I advanced it, it's 900 RPM and it's 0.011 feet per rev. This is a very simple Just a turning program. Almost done now. And then I just pull the tool up and then back to where it started. It's a lot of work it just did. Then I'll do 2 more passes.